Stealth wins the first night. Staying airborne wins the war. One jet is built to be unseen. The other is built to fly again, and again, and again. In modern combat, the scariest weapon isn't a missile, it's readiness. Because the best fighter is useless when it's stuck in a hangar. March 2024, Baltic Sea. A Swedish Gripen E is flying fast. An American F-35 patrol is nearby. The Gripen pilot boosts the engine. The jet accelerates hard and pulls ahead, not because of stealth or sensors, but because it has a lot of power for a light aircraft. Inside is an upgraded F414-based turbofan with fast digital controls and improved fuel and afterburner systems. That gives the Gripen quick acceleration, strong climb, and high energy in turns. The bigger point, raw power plus efficiency can matter as much as stealth, because it also affects costs, range, and how often a country can afford to fly missions. The Gripen E uses about 4,700 pounds of fuel per flight hour. The F-35A uses about 11,500 pounds per hour, around 2.4 times more. That difference isn't a small detail. When you multiply it by lots of flight hours, dozens of jets, and decades of service, fuel turns into billions of dollars. For many countries, the real question isn't which jet is coolest, it's which jet can we afford to fly for 30-40 years. That's why some smaller air forces like the Gripen. It's designed around efficiency plus easy upkeep, not just top-end tech. People tie that approach to a long, efficiency-first engineering tradition. Strong performance, but with lower operating cost, fast maintenance, and high readiness. Some also claim this shows up in supercruise, supersonic flight without afterburners. The Gripen E is often described as better at sustaining supersonic speed with stores than the F-35, which is limited by drag and thrust when fully loaded. Quick math sanity check. Your draft has contradictions. 600,000 pounds per month extra fuel is 7.2 million pounds per year, not 720,000 gallons unless you assume a very odd conversion. If you convert jet fuel at 6.7 pounds per gallon, that's about 1.1 million gallons per year, not 720K. If the extra cost is $2.1 million per year, then over 40 years it's $84 million total, not $84 million per aircraft. If you want the billions claim to survive fact-checking, use a simple formula instead. Extra cost equals fuel burn difference per hour times total fleet flight hours times fuel price. Modern air combat isn't close dogfights near the ground anymore. It's about getting there first, staying there longer, and controlling the distance of the fight. If a jet can fly supersonic without afterburners, supercruise, it can set the pace. The other side has to react on your timeline. The F-35 relies heavily on stealth to get close without being seen. But stealth isn't magic. If enemy radar spots it earlier than expected, the F-35 may need afterburners to reposition fast, which burns fuel very quickly. The Gripen approach is simpler: speed and efficiency. It can move fast without guzzling fuel as badly, so it can reposition more often. The biggest shift is maintenance. The Gripen's engine is built in modules, big blocks. If one part has a problem, you swap that module instead of tearing down the whole engine. In exercises, Gripen teams have shown very fast engine swaps, meaning the jet can be back flying quickly. The F-35's F-135 engine is larger, and maintenance can require more specialized support, so turning the aircraft around can take longer. Bottom line, in a real war, where you need many flights per day, speed to repair and reliability can matter as much as top-end stealth. Countries want jets they can keep flying for decades without building a giant, expensive support system. That's why some buyers lean toward Gripen-style thinking. Jets that local crews can maintain with existing bases, tools, and people, not jets that need constant outside contractors to stay ready. This is the export market reality. A fighter that's amazing on paper is useless if it's stuck in a hangar most of the time. Availability beats best specs. And that's the wider crisis. Many air forces can buy advanced jets, but can't afford to fly them as much as they want. Flight hours get cut, training suffers, readiness drops. Sweden's pitch is the opposite. Designed for high flying hours, fast maintenance, and long-term operating cost, not just maximum performance for a brochure. Now the ripple effect. Next-gen programs, like the UK's Tempest, are building engines around more thrust, better efficiency, and smarter maintenance, and Sweden's Keep It Flyable philosophy is part of that thinking. Sweden is bringing its Gripen experience, especially engine integration and easy maintenance, into newer European fighter work, like Tempest/GCAP. The idea is different from build the biggest, most extreme engine. It's more like reliable engines, lower fuel burn, fast repairs, more jets ready every day. Sweden's lesson is simple. You don't need the most powerful engine. You need the smartest, easiest to run one. Why it matters? The F-35 can be strongest early in a war, when stealth is at its best. But in a long war, where logistics and maintenance decide who keeps flying, the Gripen-style model can win. More sortie per day, simpler basing, less downtime. That's the real threat. Not that Gripen is better at everything, but that it's better at what matters when wars last months, not days.